Welcome to day 14 of Wisdom Academy AI, My Incredible Wizards. I'm Anastasia, your thrilled AI guide, and I'm so excited to be here today. Have you ever wondered how AI can make decisions like a human, splitting choices into simple yes or no paths? We're diving into decision trees and random forests, powerful tools for classification. I've brought my best friend Sophia to share the magic. Let's recap day 13, where we explored logistic regression. We learned it classifies data with magic, using the sigmoid function for yes-no decisions. We evaluated it with metrics like accuracy, precision, and ROC, ensuring strong performance. We tackled challenges like imbalanced data with smart solutions. And we classified customer churn with a fantastic demo. Now, let's move on to decision trees. I'm so excited. Today, we're diving into decision trees and random forests, and I can't wait. We'll uncover what they are, powerful tools for classification in AI. We'll learn how they work to classify data using splits and ensemble learning. We'll explore key concepts that make them effective, like how they make decisions. And we'll build a model with a magical demo. Let's classify with tree magic. I'm so thrilled. Decision trees are our focus today, and I'm so excited. They're a supervised machine learning algorithm used for classification tasks in AI. They have a tree structure with nodes, branches, and leaves, guiding decisions step by step. They split data based on feature conditions, like age or income, to classify. For example, they can classify customers as churn or not based on their features. It's a simple, magical decision-making tool. I'm thrilled to explore it. Why use decision trees? Let's find out. I'm so thrilled. They're easy to understand and visualize, making them great for beginners in AI. They work for both classification and regression tasks, offering versatility in modeling. They handle nonlinear relationships in data, capturing complex patterns effectively. For example, they can predict if a loan is risky, helping banks decide. Decision trees are a beginner-friendly spell for AI. I'm so excited to use them. Let's see how decision trees work, and I'm so excited. They start at the root node, which contains all the data we're working with. They split the data based on the best feature condition, like income or age, to separate classes. This splitting continues down the branches until we reach the leaves, which are the endpoints. The leaves represent the final classification, like churn or not churn. It's a magical path to decisions. I'm thrilled to follow it. Splitting criteria are crucial in decision trees, and I'm so eager to share. They use metrics like Gini impurity and entropy to decide where to split the data. Gini impurity measures how mixed the classes are in a split, aiming for purity. Entropy measures the randomness in the data, seeking to reduce uncertainty with each split. The tree chooses the split that reduces impurity the most, creating better separations. This is a key step in tree magic. I'm so excited to understand it. Let's look at an example, classifying customer churn with a decision tree. We use data with age, income, and purchases to predict if a customer will churn. The tree might split first on age greater than 40, leading to yes or no branches. Further splits, like income greater than 50K, refine the decision down the path. The leaves give the final classification like churn, yes, or no. It's a magical way to classify. I'm so thrilled to see it in action. Now let's explore random forests, and I'm so excited. They're an ensemble of many decision trees, working together to make better predictions. Each tree in the forest votes on the classification, combining their decisions for a final answer. This reduces overfitting by averaging the predictions, smoothing out errors from individual trees. Random forests are often more accurate than a single decision tree, improving reliability. It's a forest of magical AI decisions. I'm thrilled to dive into it. Let's see how random forests work, and I'm so thrilled. They build multiple decision trees, each on a random subset of the data, to create diversity. They also use random features for each tree, ensuring variety in the decision-making process. Each tree votes on the classification, and the majority class wins as the final prediction. This combines the magic of many trees, leading to better accuracy than a single tree. It's a powerful ensemble spell. I'm so excited to explore its strength. Why use random forests? I'm so thrilled to share the benefits. They're more accurate than single decision trees thanks to the power of ensemble learning. They reduce overfitting by combining predictions from many trees, making the model more robust. They handle large datasets and many features well, scaling effectively for complex problems. For example, they can classify diseases based on many symptoms, aiding diagnosis. Random forests are a magical upgrade to tree power. I'm so excited to use them. Here's an example, using random forests for disease diagnosis. We use data with symptoms like fever and cough to predict a disease, such as flu or cold. Multiple trees in the forest vote on the diagnosis, combining their decisions for accuracy. For example, 70% of the trees might vote for flu, making it the final prediction. This is more reliable than a single tree, reducing errors in diagnosis. It's a magical way to diagnose. I'm so thrilled by its impact. Evaluating decision trees and random forests is key, and I'm so eager. We use metrics like accuracy, precision, and recall to measure classification performance. A confusion matrix shows true positives, false negatives, and other outcomes for detailed insights. Random forests also provide feature importance, showing which features matter most in predictions. This ensures our tree magic is effective, confirming the model's reliability. Let's measure our spell's success. I'm so excited to see the results. Feature importance in random forests is fascinating, and I'm so thrilled. It shows which features influence predictions the most, highlighting their impact on the model. For example, income might be the most important feature for predicting customer churn, guiding decisions. This helps us interpret the model's decisions, understanding why it classifies as it does. It's also useful for feature selection in future models, focusing on key predictors. This gives a magical insight into AI decisions. I'm so excited to explore it. Decision trees have challenges, but I'm so determined. They can overfit, growing too complex and fitting noise in the data, reducing generalization. They're sensitive to small changes in the data, leading to different trees with minor variations. They may create biased splits with imbalanced data, favoring the majority class. They're also not great with continuous features alone, sometimes needing pre-processing. We'll fix these with magical solutions. I'm so excited to tackle them. Let's overcome decision tree challenges, and I'm so thrilled. We can prune trees to reduce overfitting, trimming branches to keep the model simpler. Using random forests stabilizes predictions, combining many trees to reduce sensitivity to data changes, balance the data before training to avoid biased splits, ensuring fairness across classes, discretize continuous features like binning ages for better splits and accuracy. These are magical fixes for better tree magic. I'm so excited to apply them. Random forests also have challenges, but I'm so determined. They can be slower to train when using many trees, taking more computational time. They're less interpretable than a single decision tree, making it harder to understand decisions. They require tuning, like setting the number of trees, to optimize performance. They may still overfit with noisy data, capturing patterns that aren't meaningful. We'll address these with AI magic. I'm so excited to improve them. Let's overcome random forest challenges, and I'm so thrilled. We can limit the number of trees and features to speed up training, saving time. Use feature importance scores to improve interpretability, understanding which factors drive predictions. Tune hyperparameters like tree count, using cross-validation to find the best settings. Clean noisy data before training to reduce overfitting and improve accuracy. These are magical solutions for a better forest. I'm so excited to make it stronger. Here are tips for using decision trees and random forests, and I'm so thrilled. Start with decision trees for simplicity, as they're easier to understand when beginning. Use random forests when you need better accuracy, leveraging their ensemble power. Visualize trees to understand their decisions, making the process clearer for analysis. Tune hyperparameters, like tree count, for optimal performance using cross-validation. Keep practicing your tree magic. I'm so excited for your progress. Let's recap Day 14, which has been a magical journey. Decision trees classify data with splits, guiding decisions through a tree structure. Random forests use an ensemble of trees for better accuracy, combining their predictions. We learn to evaluate them with accuracy and feature importance, ensuring effectiveness. Your task: build a random forest model using Python and share your accuracy in the comments. I can't wait to see your magic. Visit WisdomAcademyAI for more resources to continue the journey. That's a wrap for Day 14, my amazing wizards. I'm Anastasia, and I'm so grateful for your presence. I hope you loved learning about decision trees and random forests. You're truly a wizard for making it this far, and I'm so proud of you. If this lesson sparked joy, give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll explore support vector machines basics. I can't wait.